was our f of 0, then I need to add. Okay. So the next thing is basically what is the value of all of our derivatives? Yeah, when I plug in the derivatives are all e to the x, so when I plug in 0, I get 1 for all of them. So it's just going to be 1 divided by 1 factorial times, or x plus 1 divided by 2 factorial times x squared plus 1 divided by 3 factorial times x to the third, thus so forth. So in general, what do we get there? That's my general rule. Yeah, I have an x to the n divided by n factorial. You could also write it as 1 divided by n factorial times x to the n, but either one is fine. What questions do we have on that one? Like I said, we were almost there yesterday. That's why I said, like, this one's pretty straightforward because we end up with 1s, which is why we like E. Alright, so like I said, these are the 3 that we already built out. So this is, we looked at cosine already, which is n equals 0 to infinity. And we just found E. And we can also use some similar logic for our sine. Yes, no, maybe? Okay. So remember that it was also alternating, and it actually alternates in the same way that your cosine does, right? We start at a positive and then go negative and positive, negative, and so forth. Yes? So it will also have from n equals 0 to infinity a negative 1 to the nth power, and then I have my x, but instead of my evens, what do we end up with? We get the odds. Okay, so I don't want it to be just n though, because then I would still be getting all of the stuff in between, and we want to skip some. Agreed? And I need to for sure make sure that we get all of the odds. So what would we do there? 2n plus 1. Which then also remember that those match our factorials. So that's also 2n plus 1 factorial on the denominator. And like I said, these are the 3 that you kind of need to know, or at least recognize. And the main reason for that is, like, it's, I won't say guaranteed, but there's very, very good likelihood that one of these will show up on the AP test. So it just makes your life a little bit easier if you can remember it. If you don't, then remember you can always write out the first couple of terms and hopefully then recognize what it would be. But that just takes a little bit of time. But worst case scenario, that is what you can do. Questions on those 3?
On the test, like, would they end up asking us a question where we have to make our own up for anything they give us? Yeah. Okay.
Yep. And I mean, it would be a similar process though, right? Like, I would write out like my first few terms, and then there's going to be some sort of pattern, and so then I'm just going to write that as, they're not going to give you anything that's just like super ugly, right? It's going to be a fairly simple, like, straightforward pattern. Like, I'm adding 1 to my factorials, or I'm doing whatever, like, to my factorials, or whatever it may be, that then you should be able to write out the pattern from it. Which is why we practiced pattern recognition in our last unit, so that we could kind of get okay at that. Other questions?
So is the +1 basically just giving us a phase shift so that it lines up with cosine?
The +1.
When we do n + 1 or 2n + 1?
Except that's on sine, not cosine.
Mm-hmm. Is that just so that the two are?
It's not really a phase shift, it's more like because sine is an odd function and cosine is an even function. And so I need even degrees versus odd degrees. And the way we do that is like even numbers, remember I can always divide by 2, so that's why we get a 2n. And then odd numbers are always going to have a remainder of 1 whenever divided by 2. So that's where we get the +1 from.
Is it always going to tell us the amount of degrees that we need? Or are we going to have to figure it out sometimes? Like,
the only other way that I would ask it, like I kind of like what I talked about yesterday, would be like if it said, it's either going to say the nth term, right? So like kind of how I did on this one, right? So like on this one, I didn't technically need a specific number of terms. It was mostly just write out enough of them so that I can start to see the pattern. Now, if it asks you for like an actual polynomial, it's going to have to either give you a degree, so it'll say the 7th degree of Maclaurin, okay, or Taylor if it's not centered at 0, or it would say write the Maclaurin polynomial with 4 terms, right? So then, like on this one, that was kind of what we talked about. Remember, in order for me to get 4 terms, I technically had to go out to 7 because it was skipping every other one. So it's either going to give you the number of terms or the degree that it wants. Now I will say the AP test is usually nicer and it's not going to make you go out to the 7th degree. Usually it's only going to be like maybe the like 3rd or 4th is usually like the top that you'll see. But for us here, it was just good for us to like see what it kind of looks like as we build it out. Other questions? So we have one more. That's not sine, cosine, easy x. So we looked at this for a while. So it says writing a Maclaurin polynomial using known information. So a function g of x has derivatives for all orders of x equals 0. It is known that g of 0 equals 2, g prime of 0 equals -1, and g to the nth, so meaning the nth derivative of 0, that cut off my bottom part, is n squared divided by, that should be n factorial, for all n greater than or equal to 2. Write a 3rd degree Maclaurin polynomial for g of x. So this way kind of, we're going backwards this time, meaning that it gave us the nth kind of rule there, and we're going to use that to plug in for our derivatives. We're going to go ahead, and I would highly suggest your first step being just to write out the general equation before you start plugging stuff in, right? Because again, it's a little bit, like it has a lot of moving pieces with it, and so it can be easy to like start making mistakes if you don't go ahead and write out the actual formula first. So I'm looking for p sub what? 3. Okay. But I still start with what? The constant, right, which is just going to be my g, and we are looking at a Maclaurin, which means that we're centered at what? 0. So I have g of 0. Plus, then we're looking at what?
g prime of 0.
G prime of 0 times, just times times x. Plus
G double prime.
okay, of 0 again. 2, okay, times, okay, I have 3 terms, can I stop?
No.
No, because I need a third degree, okay, what comes next?
G triple prime.
Of
Over 6 of x.
0 divided by 6, yes, or 3 factorial, times x
X to the 3.
cubed. So notice that they're nice and they gave us 2 things to start with. So what is g of 0? Okay, and then what is g prime of 0? Okay, so I should get 2 minus x there. Are we okay with that? Then, for my next 2, we actually have to do a little bit of thinking. Okay, so I have g double prime, right? Which, what's my in if I'm looking at g double prime?
2.
2, right? So g, we don't normally write it that way. We write double prime, but I'm going to go ahead and write it that way just so that it matches, okay? Which means then, what am I plugging in for n?
2.
So I have 2 squared divided by
2.
2 factorial. Yes? Okay, so then what would I get there? Plus, well, yeah, but I need like that first, right? 2 squared divided by 2 factorial divided by 2, right? Which is one of the reasons why I had to write this out first, because otherwise it would be easy to drop that 2. Yes? Because this is from my 2 factorial, this is from my derivative. It just happens to be that my derivative also has factorials in it. Are y'all with me? Okay. Times, and then yes, x squared. And then what do we also need? G of 3, which is going to be free response question, can I stop there?
Yeah.
Is everything from there just numeric? Yeah. Okay. Once I do have to plug into this formula and get actual values, but once we're there, we can stop. Now, if it was a multiple choice question, they are going to simplify that. So we get 2 minus x plus, well, this would become divided by, or times 1/2, yes? Yes, so this would be 4. 2 factorial is still just 2. Times 2 gives me a 4 on bottom as well, right? So that just ends up being 1.
Squared.
So I should get x squared. Similarly, if we reduced our second one, we get
9 out of 36, which would be 1/4.
we get 1/4 x cubed. Because you get 9 divided by 6 times 6. Because I have both this 3 factorial and that 6. Questions on that? So again, none of these are necessarily in and of themselves hard. There's just a lot of moving things, and you have to memorize that formula. But questions about our Taylor or Maclaurin polynomials?